But for our first page, let's ask, what is an application? I come from an economics background. So let's take my expertise and let's, for example, from your end, depending on what you're learning calculus for, you might be a pure mathematician, but a lot of people have an idea of what they want to eventually do for a living or their specific application, or already have the application and just want to make their application stronger through math. So I'm saying, okay, let's pick the field of economics. I'll look at all these fields, actually, others that I don't have as much expertise in. But we're going to just say, okay, ChatGPT, could you give me an application for economics, or let's say for domain and range in economics? So here we go. Interestingly enough, we have a profit function, quadratic function, and we have a profit function where we have to ask, okay, what are logical values that go into the function? Sometimes this comes from a mathematical point of view, and other times you might say, okay, this comes from a point of view based on the application at hand. So we're talking about profit, a profit function. And what domain here in a mathematical sense would be from negative infinity to infinity. You could define this function from negative infinity to infinity. But in this context, we have to be careful and say, well, my profit function doesn't make any sense for x less than 0. I can start with x equals 0. I am going to, for the most part, I got to be careful here and just say I'm plugging in integers. It depends on what the units are. If it's in terms of thousands, for example, let's say x equals 1 is 1,000, then decimals could make sense. But it depends on how you're breaking this down. Let's say if x is in whole units or integer units. And this is a neat thing that ChatGPT has given us. Maximum number of units you can feasibly produce, say 70 units due to labor, time, or resource constraints. So what I'm going to mix in here is just how I take a look at this type of problem, even from my economics perspective, and give you a little background of what I know there. So what we're going to start off with, let me do a copy and paste, is we're going to take this profit function. And let's run with it. We have x equals 0 through 100, or 0 through 70 for the domain. And this is where you can go in a lot of different directions on what you know from past things you've learned from your field as a study. X is going to be 0 to 70. And let's say these are units, integer units of production. And you might say, okay, of course, they're integer units. Not necessarily. Let's say if we're talking about, let's say, sandbags or something. You could say perhaps by the end of the day, you might be filling 50 pounds of sandbags, and for whatever reason, you might quit at half of the bag being filled. So you can define the values, x equals 0 through 70, and also say x is an element of integers, and we're restricting x to be between 0 and 70. I'm a little rusty on my set notation. I haven't taught that type of course in a while, but this, of course, the Z is shorthand for integers. You might say, why in the world do I not use I? I might be a little confused with the imaginary numbers. But let's dive in and see what this is all about. Now, let me explain this little background and how we can go deeply into this problem. X equals 0 through 70. We say y 70. Here I'm going to use my economics background to explain the details, what ChatGPT is telling me behind here. Say 70 units due to labor, time, or resource constraints. Well, time, so we're going to have a function of labor, time, or resource constraints. All right. Let's put it this way. The time, we're going to say in dollars spent per unit sold. So we're going to have time, resource constraints, and labor. So a function that explains production, let's say X is our production. Production, we can say depends on labor, and examples of other they threw in the mix here, not just labor, but resource constraints. Well, resource constraints, we could say land and capital. So we can say we have a function of labor, land, and capital. We might have fixed resources here. And it mentioned time as a variable also. Let's say this is a, let's say weekly profit. So you could say, is this daily profit? Is this a, it depends on the different context, but a company has fixed short-term resources. I say short-term because let's say if their demand is consistently nearing 70, they might at some point say, hey, we need to hire more people. We need to make capital investments. What we mean by capital is, let's say, machinery and tools, for example. So in the short term, we're going to say these resources are fixed. So we can define our production by this function. P of x equals negative 2x squared plus 120x minus 1,000. So we'll be curious about this profit function and look at different aspects of it. So on the one hand, we have x equals 0 to 70 due to the fixed resources in production. Whoops, I got a moth here right in front of me. That's a new one. Anyway, we have fixed resources in production. X equals 0 to 70. Now, what that is in calculus terms, that's called my domain. The domain are the possible inputs that you could put into the function, while the range is your defined outputs. So the output's going to be the profit itself, while the X is going to be number of units sold. And let's say due to fixed resources, I can only produce so much. I'm going to be able to produce 70 units max per day. And it could be something what we would call, let's say, some goods are durable, so you could produce one day and keep an inventory. But you could also have goods that are not non-durables. Let's say food, for example. If we're in France and we're talking about, let's say, loaves of bread, they don't keep bread for the next day. Yeah, just a little tidbit there. The emphasis is on fresh quality product. They're not keeping it for the next day. It gets thrown out. they start the production anew the next day. So you can think of X units sold. It could be, let's say, loaves of bread. And the range is your output profit for that day. And what a company has to look at is what is my optimal, let's say for profit, they might want to say, okay, what's going to be my optimal production and what should I produce at given these resources? I can maximize up to 70, but that might not, what we would say, maximize our profit. At this point of the course, we're going to assume that we don't know calculus. To answer that question, how do I maximize profit? How to maximize profit? And you realize, let's say, realize the possibilities. Well, if I say, okay, realize the possibilities, how about we start off here? We're saying, okay, x equals 0 to 70 is my domain. What in the world is the range? I'm constrained by not knowing calculus at this point in this video series. But let's look at the range and talk about how I can think about that. I'm going to think about it graphically, actually. So just out of curiosity, I say, hey, maybe someone joins. Who knows? It'd be weird. Someone will just like randomly jump on YouTube and run into this. Anyway, sorry about this. I'll get better with YouTube as time goes by and come up with better equipment and so forth. We'll see what this is all about. So anyway, this video's gone a while already, but I just want to share my, way I look at these things and share, some background I have from my own studies. What I'm going to go with next is I'm going to say, okay, -2, 120, and -1,000. Try to remember that as I set this up. I went to ChatGPT. Sorry for my clumsiness. I certainly do not want to show anything on my work email. Let me get that in behind here. Sorry about this. Sorry, not sorry. I'm learning. I just don't want to be a buffoon and show something I shouldn't. I don't think I have. So, okay. 0 to 70. Now we're going to discover the range. It gives you an example of the range, and it gives you this definition of x equals -b over 2a, a function that doesn't use calculus, but it looks at a parabola to find the maximum profit. I'm also going to go to Desmos. So I can graph y equals -2x squared plus 120x plus minus 1,000. And you look at that graph and you say, I don't see anything yet, right? Ooh, look at that. It's at -10 even. Let's do something here. What we have is a classic case, and this is a great case to illustrate why it's important to know domain. Whoops. I typed 1,000 in a weird way. No, I didn't yet. We're going to write the 1,000. The 1,000 all the way at -10 is at 10. I'm getting a really weird graph at this point. But let me go to gears and change this axes. Let's say from -5, but now to -70 to +75. Knowing the domain of my function allows me to realize the relevant parts of the graph that I need to show. Now, let's look at different values of x as you're trying to say, okay, what can I plug in? Well, I'm trying to explore this function and see the different values that can occur. one key value I can plug in is x equals 0. I would get negative 1,000. Then you might say to yourself, okay, I see negative 1,000 and then the rest of my graph is missing. What do I do with the rest? Well, you'll notice even if I plug in x equals 1, I lose $2, but I gain 120. So I'm going to have a growth in my profit when I plug in certain values of x. Where that growth ends could be a mystery at this point to me. It is a mystery if I'm relatively new to calculus. But I can start to explore it with different values of y, and I can plug in, let's say, I can plug in 10, I can plug in 1,000, I guess. Here we go. Here's the graph. And here's the illustration of my potential in this, be it bread business or whatever it may be. And look, I really lose a lot of money past a certain point, surprisingly. Even worse than if I produced nothing. So I'm going to show the illustration here. Let's say cut it off at 70. Whoops, sorry about that again. Ooh. Okay, easy way to correct. Let's go not negative 1,000, but negative 2,500. And you might say, why in the world did you do that? To 1,000. And I'm going to go from negative 5 to 75. So I'm changing the x and y axis here to make the graph more friendly. And yeah, this is going to work out good here. So this is what I did and why knowing something about domain and range is really important here. Or actually, I'm just showing you what you might have played around with in discovering calculus or discovering math and seeing why it's so important here. The reason why it's really important in the application of economics is I want to take a look at a graph. I have to have an idea of the relevant domain because these values of 0 through 70 are the values that I care about. So I have this business. I have my X units that I produce. And here's my profit function. And I see a graph with the different values that can be produced. We start off with 0. I'm going to explain this in both a mathematical and economics context. 0 and negative 1,000. This is due to this being the y-intercept. So if I plug in x equals 0, my function is negative 1,000. This is called the y-intercept because this is where the graph crosses y-axis at x equals 0. So I plug in x equals 0 and I get negative 1,000 as a result of that. Great, I get that negative 1,000. This is a y-intercept in mathematics. So you plug in x equals 0, and the reason why we care about that is because it's an easy to find point. From a mathematical context, if I had to graph this from scratch, it's an easy to find mathematical point, negative 1,000. Okay. Now, a maximum point from a parabola the maximum point from your parabola would be negative b over 2a for a function like a, sorry about this, but for a function like ax squared plus bx plus c, we have x star equals negative b over 2a. My function was negative 2x squared plus 120x minus 1,000. Plug in negative 120. We have a 2 times negative 2. And it's telling me that x equals 30 is a special value, and I see it on the graph. For a parabola, this function gives you a max or min. From a calculus sense, if you know a little calculus already, you could also take the derivative 2ax plus b. Here's a preview of calculus. If you're watching this video, please note you shouldn't feel obliged to know this already. This is a preview of calculus. If you already know calculus, well, you're just enjoying the different possibilities here. But if I algebraically solve this 2ax plus b for x, that's where the negative b over 2a comes from. You're going to learn this from in calculus later on, how to take a derivative and find max and mins. But here's what we're at the mercy of. Now, here's something interesting from an economic context. We want to maximize profit, but often we don't maximize profit just at maximizing production. Here we're talking about, just for example, a French bread company, and they could make 70 loaves if they wanted to. But they're discovering, based on their past sales and based on this function that describes their profit, that 30 is actually an optimal number. If they go to the point of 70, it seems like at 70, I'm at negative 2,400. So what's happening after the point of 30, I'm going to be losing money under additional production. So simply put, we talked about the scale of this business before. A bakery is a great example of it. A bakery is going to have relatively short-term fixed resources. They can only produce so much. And if they overproduce, it might just not be optimal for that business, for that scale, for that economic scale. So if you have something, let's say, like called perfectly competitive firms, or even, let's say, not perfectly competitive. No, I don't mean imperfect competition, but let's say, let me keep this perfectly competitive or relatively competitive. Let's say relatively high competition. This would mean we'd have a lot of firms who could enter the business. We only have enough, if you're a bakery, there's something in economics also called monopolistic competition, where you can also compete through quality. So you have many competitors, but you differentiate by quality. So if you're a French bread maker, for example, A French bread maker is not perfectly competitive. It's what we call monopolistically competitive. There's tons of bakeries in France, but this is not your, white bread from the store. This is French bread. It's really specialized by quality. So it's got to be fresh for the customers. And and France has a lot of, bread making. It might be more perfectly competitive than monopolistically competitive. But certainly we can relate, we get our grocery store bread. It's okay. It serves a purpose. But the great bread is the fresh bread right out of the oven from a bakery. That really gets everybody's juices flowing as far as, loving bread is concerned. Not just as let's say, not just as a nutrient. Anyway, I'm rambling here, but let me make this point here. 0, -1,000 has something to do with economics. This is called a fixed cost. So your fixed cost, you're already 1,000 in the hole, regardless of if you're going to produce or not. So we're talking about relatively fixed resources for this company. So French bread company, relatively fixed resources. Well, think about their land, labor, and capital. The land, they, let's say, rent a store space in a populated area. Capital, they got their machinery that makes the bread, and their labor, they got their bakers. You're paying these people, you're paying rent on the equipment, regardless of if you produce a loaf or not. So you're paying 1,000 automatically, but as you produce more and more, it is possible to become profitable. So here's the profit function graph from Desmos. Just a basic graph. We see at the peak, we have a peak at 800. So let's go back to the concept of domain and range. The domain, as mentioned earlier, 0 through 70, this will imply a possible range going all the way down to 2,400 if you're just producing at max capacity and it's really just you're stretching your resources too thin. But you also have a maximum, a smart point of production at x equals 30. So somewhere in between 0 and 70, this is what we would call an optimal choice. You make your optimal choice to produce 30 units and produce a profit of $800. If you don't run at all, you lose 1,000. You don't want to do that if you can improve upon that. We have improved upon it. And you don't want to have the argument of maximizing production. Maximized production is even worse than not producing at all. So interestingly enough, P of 0 is better than P at 70. I only lose 1,000 at 0, yet if I decide to go nuts and say, let's go max production, I lose 2,400 at max production. And you wouldn't want to even go to the point of 60. 60, you're at negative 1,000 again. But that makes no sense to produce at that point because you're making worse profits. And then also here at 50, this is a point where we have 0 profits. This is a point where you have 0 profits at 10 and 50. Economic theory actually says perfectly competitive firms must have, eventually in a little bit of a longer run case, they must have 0 profits eventually. So you have to have enough production to keep your workers and pay your bills, but you're not going to have extra profits in a more perfectly competitive market, because with extra profits, others can see bakeries are profitable, I'll get in that industry. So if you go away from a perfectly competitive industry and you'll not go away, but if you're in a perfectly competitive industry, if you start making profits that are positive, other firms will join and will dilute the market with more bread makers. Okay, I've really explained this in a lot of detail here, but let me just have you appreciate, here's a domain and range, and this was due to the context of the problem. So the context of the problem, I can produce anywhere from 0 to 70 units, but there is a possibility of losing as much as 2,400 if I don't know what I'm doing and I'm producing too much. Yet I can produce a profit as much as $800 if I dampen production significantly. So I dampen it, but when I dampen it to 30, I end up with profits of 800. Just to specify here, in perfect competition, other firms, not in the short run, but in the medium and long run, will say, hey, look, that bread business looks like it's profitable. Let's join. But if you have more firms join, eventually this 800 will drive to 0 in a perfectly competitive market. But with monopolistic competition, I'd say there's a little bit of an opportunity for profit, because people will pay more for your product if it's a quality product. So they'll pay more for quality, or you think they're going to pay more. This depends on if, let's say if you produce 30 units in a given day, you're going to discover if you could sell all 30. If you sold all 30, you might say to yourself, why didn't I have more to sell? Or why didn't I raise the price? But if you raise the price, then customers are sensitive to that and may not show up to buy. There's a lot that goes into that model. So I say there's a lot that goes into that model. Just realize the specifics of our model. X can be between 0 and 70. This is the graph of the profit function. You don't want to make 0 profit like 50-0 or 10-0. You want to drive toward maximization. That drive toward maximization is 30 and 800. And so you maximize at 30 and 800, but this is not a calculus problem per se. It's a pre-calculus problem. It asks for domain and range. The graph helps me find the range because I can see on the graph the worst case scenario was 70 units. But we also have a relatively poor scenario if we produce too little. Interestingly enough, if you produce nothing, your fixed cost is $1,000. You leave and you lose $1,000 on, let's say, the gamble of your work. But you just say to yourself, okay, I lost $1,000. Let me go back to what I was doing before, or maybe not even look to be an industry. Sitting on the sidelines is literally better than being committed to this industry at negative 1,000 if you produce nothing. But if you produce something, and let's say in this model we are saying we're producing between 0 and 70, the maximum profit for that production is at $800 for 30 units sold. Okay, I'm getting sleepy as I read this, but yeah, this is my first exploration of YouTube, and a lot of different pieces here. They all stop sharing. Okay, I'm sorry, I unmuted myself. Hopefully my audio came okay. I only see I see a green bar. It's kind of tough to make that second green bar pop up. You're seeing a weird perspective of my screens. But if I try to yell a little bit louder, nope, It's only going to 2, but I think it's working fine. Okay. So thanks for anybody who is watching this in the end. This is just the first of many, let's say, video series. I'm not going to rush these at all. These are kind of for my own leisure, and I want to see how this goes by experimentation. Eventually, I want to get these neater and make them more visually appealing and, make it really quality. At this point, I'm just experimenting. No apologies offered here. I just want to kind of break the ice on YouTube and set this up. All right. Thank you very much. I probably am talking to nobody. I'm talking to nobody live, I think. No one in the chat, and I don't expect anybody in the chat. I'd probably be horrified if someone showed up and I'm like, I'm just experimenting with YouTube. So now this includes like a rant. But all right. Thanks so much. Bye.